Everyone, so welcome back to my YouTube channel. So today we'll be studying about grammar, regular grammar, context-free grammar, and then we'll also be covering ambiguous grammar in our next video, or if time permits, in this video. So let's start. So what is grammar? Grammar is a set of four tuples. Tuple that contains four elements, that is V, T, S, P. Now let's see each of them. V stands for set of variables. T stands for set of terminals. Then S stands for starting state. And your P is set of production. Now we know what is language. Language is basically the set of strings that we used to see, that we have seen also in our previous video, like set of strings like epsilon, A, triple A, double A, and so on. This is all a language. By production rule, we form a grammar. Let's see. So suppose we have production, let's say we have L is equal to A, comma A, comma triple A, comma so on. So we can write this as A plus. Now, in terms of grammar, how do we write? So S epsilon slash S A. That means that on recursively you'll get A, and when you want to end it, you can end it in epsilon. But this is for your A star. What if on the first one only you get epsilon? Then that is what. So now we have type 0, type 1, type 2, and type 3, which we'll see on our next slide. So type 0. Type 0 grammar states that U is tending to V. That is, U contains at least one variable. This U should contain at least one variable. Type 1. Type 1 says that your mod of U should always be less than equal to mod of V. Then type 2 will say that your U must belong to V. V stands for your variable. And type 3 says that V should be belonging to T asterisk V. Multiple terminals followed by one variable. So in this type 3, we can have one is what is known as left linear grammar and right linear grammar. So now we'll see some examples. Suppose we have A, B given A. So we have at least one variable on the left hand side that we have two. So this is your type 0. So next A S A B A slash A slash B. Now you will see that we have two variables here. One. Similarly, this is also your type 0. Now let's take an example of type 2. Type 2 example is A epsilon. This is an example of the type 2 grammar. Type 2 grammar states. So this is an example of your type 2. To better understand this, let's understand this in a form of a table. So let's make a table. So first of all, for type 3, our language is known as regular language and grammar is known as regular grammar. I'll denote it by L and G. And then your machine is an NFA or a DFA. NFA or DFA. An example of this is A asterisk, B asterisk. Then we have type 2. Type 2 is known as context-free language and context-free grammar. Here we form a PDA, push down deterministic automata. Example will be A raised to power n, B raised to power n. So now next, type 1 and type 0. And PDA is known as push down automata. This we'll learn in this. It is like a stack. Like we take a stack, we have Z at the bottom and then we insert elements and then pop them out. We'll cover this later on. So type 1 stands for decidable languages. And this is known as context sensitive language. In this we form linear bonded automata. This will not be covering, but for your information, E raised to power n, B raised to power n, C raised to power n is the example. Then type 0 is known as computable language. It is unrestricted grammar. It is used in Turing machine, which we'll cover later on in factorial. So now let's see on our next slide regular grammar. First, we'll start with regular grammar. So now let's start with regular grammar on the next slide. So our topic is regular grammar. What is regular grammar? A regular grammar is basically first of all of two types, right linear and left linear. In right linear, a grammar is said to be basically right linear if all the productions are of the form A is XB on the right and this is also right linear. A comma B belongs to variable and X belongs to terminal. And left linear, a grammar is said to be left linear if all the productions of the form A tends to Bx or A tends to X, where X is your terminal and A and B are your variables. You can remember by this capital B, this is on the right, this is on the left, and your terminal is on the vice versa side. So this is the basic difference. So let's take example. So example, suppose we have S tends to A, B, S slash B. Here we can see that your capital is on the right hand side. So we'll say right linear grammar. Now next, S, B, B slash A, S on the left hand side, left linear grammar. So now before starting questions on this, we'll cover one more topic, which is pumping lemma. Yes, so let's start pumping lemma. In pumping lemma, basically pumping lemma is used to prove that a language is not regular. Therefore, if A is a regular language, then A has a pumping length P, pumping length capital P, such that any string s mod is less than greater than equal to p may be divided into three parts: x, y, z. And the following, there are three conditions. The first condition states that x, y raised to power I, z should belong to A for every I greater than equal to 0. Let's suppose we have E raised to power n, B raised to power n. So we have a string A, B, B, B. So we take this as x, this as y, and this as z. So basically we are dividing the string into three parts. Then when we say x, y square z, I mean A, A, B, A, B, B, B. Does this belong to A raised to power n? No. It has different combinations of A and B. Therefore, first property is not satisfied. Similarly, this was the first property. Let's go on to our next property. So our next property states that mod of y should be greater than 0. Next, mod of xy should be less than equal to p. So now let's take an example to understand this better. So we took the example of A. Please remember when we say mod of xy, just wait a second. So yeah, when we say mod of xy is less than equal to p here is your pumping length. It can be referred as n also at some places. That means the size of x and y should be less than or equal to p. Suppose there are 5 A, B, B. So your x is A and this is x, y, z. Your p is, let's say, 2. So your size of x and y is 1, 2, 3, 4. So 4 is less than, so this condition will not be satisfied. To power, we took the example of L is equal to A raised to power n, B raised to power n. This was the first example that we had taken, and we had seen that the first property is not being satisfied. How? I told you when we are taking square, it is having different combinations of A and B. But that is not the way to solve. You have to solve in basically three cases. One, case 1. Y contains only A's. Then case 2. Y contain only B's. And case 3. Y contain A and B. So if we take this case, suppose we take any string A, B, B. Only A. So I'll take this as X, this as Y, and this as Z. Any combination. Then if I say X, Y square Z, A. Now 2 times, this should become 4 times. Then B. A is 5 times, B is 3 times. Is it satisfying A raised to power B raised to power n? No, it is not. Therefore, xy square z, you write like this, xy square z does not belong to L. Similarly, in only B, suppose we are A, triple B, and we take this as x, this as y, and this as z. Similarly, xy square z will be triple A, 4 times B, and 1 more B. 3 times, 5 times. Therefore, not satisfying, xy square z does not belong to L. Similarly, in case 3 that we had seen earlier, we proved that x, y square z does not belong to L. Therefore, we can say by pumping lemma, L is not regular. So now we'll see another example. We proved that it is not a regular language. Now after this, what we'll have to do is we'll have to check for this condition x mod of xy is less than equal to p. When you check this condition, your question will be proved successfully. If you only do the steps that we have done on the previous slide, it will not be a fully solved question. The next example is L is y such that y belongs to 0, 1 asterisk. We have to prove it using pumping lemma. So now w is 0 raised to power 5 into 1. This is y, so again we write y. This belongs to L. In this also will take case 1 only zeros, case 2 only ones, and case 3 both 0 and 1. When we take only zeros, we can take any number of this. Suppose 0001, 0001. So x, y, z. So when we take x, y square, z, this will become 4 times. Will this belong to z? Will this x string still be equal on their RHS? That means here we have 0001. Will we have 0001 here? No. So does not belong to L. In only ones, it's 0001, 0001. So only one, suppose this is y, this is my x, and this is my z. 0001100001. So I see this is my first string, this is my second string. This is not belonging to L. Why? Because I can't see y here. In both 0 and 1, 0001, 0001. 10 we take as y, this as x, and this as z. So the 00011010, then 001. Can we have a same combination on the this side and this side? No, we cannot. So this does not belongs to L. That means that this is not a regular language. Now next. Now, so that's all for this video. In the next video, we'll do some more questions on regular grammar, because today we mostly covered about pumping lemma and covered its questions. We have a basic idea of what regular grammar is. In the next video, we'll have a more clear understanding on what is type 2 and type 3. Type 0 and type 1 will not mostly be covered in this course. So thank you. Have a great day. If you like the video, do like, share, and subscribe. Thank you. Bye bye.